Good morning, everyone. Welcome to the 2019 Wagner Prize Competition. We have 5 excellent presentations today, 3 this morning in this session and 2 later this morning at 11 in the same room. This prize, the Daniel H. Wagner Prize, is sponsored by the Informs Practice section. It was established in memory of the late Dr. Wagner. The 5 finalists presenting today will be judged on success in practice, quality and coherence of analysis and solution originality, quality and clarity of writing their papers, quality and clarity of the oral presentations, which is today. As background to the prize, a brief introduction to Dr. Daniel Wagner. Dr. Wagner earned his PhD in mathematics from Brown University. Upon graduation, he joined the Navy's Operations Evaluation Group at the Pentagon, working in operations research for naval warfare until 1956. After 1 year as a postdoctorate at MIT, Dr. Wagner joined Burroughs Research Center, where he directed a group of mathematicians performing analysis for the development of digital computers. In 1963, Dr. Wagner formed a new company, the Daniel H. Wagner Associates Incorporated. During his years as president and principal owner of Daniel H. Wagner Associates, Dan brought many high-quality mathematicians into the operations research community. This led to significant advances in mathematics for naval tactics, especially anti-submarine warfare, detection theory, and search planning. Wagner Associates delivered significant applications to the Navy, Coast Guard, and other clients, many of which are still in service today. It's pretty amazing. After retirement from the firm, Dr. Wagner founded, he continued his commitment to the field of OR, serving in various teaching and research positions with the U.S. Naval Postgraduate School and the U.S. Naval Academy. He was an active member of ORSA and then Informs for more than 40 years. Amazing service. The idea for the Wagner Prize began at Dan's memorial service, where many of his former colleagues gathered. The prize is made possible by a generous endowment from firms Metron Incorporated, Daniel H. Wagner Associates Incorporated, and Applied Mathematics Incorporated. I'd like to introduce the members of the 2019 prize committee. They are Bill Browning, who is not with us today, Alan Butner, Larry Stone, Margaret Yarndaughter, Brian Eck, Pavitra Harsha, Kankitzer Siaglu, Eva Ragnier, Emily Tucker, who is our graduate student member, and myself, Mary Hollander. I'm the chair of the committee. Without further ado, I'd like to introduce the first speaker in today's presentation. From Bucknell University, they'll be talking about daily tutor scheduling support at Hopeful Journeys Educational Center by Professors Matthew Bailey and Lucas Waddell.
All right, good morning. So I'm Lucas Waddell, and this is my colleague, Matt Bailey. We just want to start by thanking the Wagner Prize Committee for this incredible honor. We're so excited to be here, and we're especially excited to hear about all of the great work being done by the other finalists. So today we're going to talk to you about a project we work on that improves the day-to-day lives of a very deserving group of people. So Hopeful Journeys Educational Center is a school in Beverly, Massachusetts, just a little bit north of Boston. And the school's mission is to provide quality and individualized education to children with autism spectrum disorders and other developmental disabilities. And I couldn't resist the urge to go onto their website and pull some of these amazing photos to share with you all this morning. And so what I hope to convince you of is that Hopeful Journeys faces a fairly intense daily scheduling problem that involves the one-to-one scheduling of about 100 tutors to about 100 students from 8:30 in the morning to 2:30 in the afternoon within 30-minute blocks of time, 5 days a week. And the creation of this daily schedule is the sole responsibility of one person, the school-wide scheduler. His name is Joe Protz. And Joe took over this job in the fall of 2018, last fall. And basically his daily process was that he would sit in front of his computer, pull up Microsoft Excel, cross-reference over 30 different spreadsheets, and by hand create this schedule. And this was a very challenging, frustrating, and error-prone process for him. In fact, Joe estimated that he would spend about 10 to 14 hours per day by hand making the schedule for the next day, and this process would repeat every day. And so as you can imagine, this was not a sustainable solution for Joe or for Hopeful Journeys. But Hopeful Journeys didn't have the budget to go out and hire a consultant to help with this problem. So Joe ended up posting on a Microsoft Excel message board, basically asking for help. And Matt and I happened to see this post, and after reading his comments, we realized that this problem probably required a little bit more sophistication than just a simple spreadsheet solution. So we reached out to Joe directly, and after hearing more about the problem and the amazing mission of his organization, we decided to try to help out if we could. And so one thing I want to mention right off the bat is that even though helping Joe save time and improve his life is a very worthwhile goal, and he definitely deserves that, that wasn't the main purpose of this project. There are actually two other reasons why improving the scheduling process at Hopeful Journeys was a really important thing. First of all, there were many more amazing things that Joe could do with his time than sit here for 14 hours a day creating this schedule. Things like program development, tutor training, things that were much more fitting for a man of Joe's experience and expertise. And secondly, these error-prone schedules presented a really big problem for a school like Hopeful Journeys. Joe described that every day at around noon, there would be what he called a midday scramble, where it was basically chaos because of errors and omissions in the schedule. Things would need to be shuffled around. And the reason this is an especially big problem for Hopeful Journeys, and I want to read a quote here, from autismspeaks.org, one of autism's primary symptoms is a need for an unvarying routine and a resistance to change. So if you can imagine how upset you get at schedule changes, imagine how big of a problem this was for the students and the staff at this particular school. And so hopefully I've convinced you that this is a worthwhile project to work on. You might be thinking it sounds like a fairly standard appointment modeling or appointment scheduling model. But the truth is that there are a variety of conditions that make this a non-standard personnel scheduling of resources, the tutors, to jobs, the students. And just to give you a little bit of insight, there we go, a little bit of flavor into the complexities of this problem, I want to walk you through some of the things Joe has to consider when creating this daily schedule. So students have varying demand for tutoring throughout the day based on things like absences, doctor's appointments, early dismissals, and also each student has a limited set of other students that they can actually be paired with. But this is to be avoided if at all possible. Hopeful Journeys really values one-on-one tutoring that's best for the students. Also, an individual tutor's availability varies throughout the day based on things like meetings, days off, and each tutor has to be scheduled a 30-minute lunch break, and there are two priority classes of tutors. There are managers and staff, and managers really should be avoided giving tutoring responsibilities if at all possible. And then there are a variety of other conditions here. A lot of these tutors have very specialized training, and a lot of the students have very specialized types of needs. And so tutor qualifications for working with particular students varies. Also, the tutor scheduling duration can vary from the preferred 1 hour to a shortened 30-minute period to an extended 1.5-hour period. But this 1 hour pulse is really what's best for the learning outcomes of these children and also the work life for the tutors. Students have preferred sets of tutors within assigned teams. Hopeful Journeys has about 10 teams with 10 students and tutors on each team, but tutors from other teams can help out if they're qualified and if they're needed. And then there are daily limits on total time with each student and total successive time with the same student. So this is exhausting just reading this list. Imagine being Joe and having to work through all of these different conditions every day when he's creating these schedules. And so to kind of get a foothold on this problem, we looked at the literature, and one of the first papers we came across was this survey by Vandenberg in 2013, where he looked at over 300 different appointment scheduling papers. And unfortunately, only about 15% of those were applied in practice, and education wasn't listed as an area of application. Now, there has been a lot of work done with timetabling in the world of education, assigning instructors to courses and time slots, but the Hopeful Journeys problem was a bit more complex than that, and it actually, we came to realize, had a lot more in common with physician scheduling models. And so in 2018, excuse me, in 2018, Schoenfelder and Pfefferlin called physician scheduling one of the most complex topics in personnel scheduling due to the high heterogeneity among individual employees with respect to qualifications, as well as the demand for very specific workforce compositions. So the Hopeful Journeys scheduling problem shared a lot of these complications, but in addition to this, there were these 4 extra challenges that really drove most of our modeling decisions. So first of all, Hopeful Journeys needed a cost-effective, in other words, a free solution. So like I said before, they didn't have the budget to hire consultants or buy licenses for high-powered optimization commercial software. Also, the preferred software of use was Microsoft Excel. This is what Joe was comfortable using and what he preferred to use going forward. Additionally, they needed a tool that could be run every day and require no maintenance or optimization experience to run. So Joe basically wanted to be handed this tool and run it independently of us without the need for troubleshooting and things like this. And finally, and probably most importantly, they needed help with this problem yesterday. This model that they had of Joe spending 14 hours a day working on the schedule wasn't sustainable. So they needed a solution to this problem, and they needed it very quickly. So a few more details about the model that we ended up developing. So we went with a binary integer programming approach rather than, say, a heuristic method for several reasons, including ease of use and ease of implementation. Also, Also, with a heuristic approach, you can terminate the algorithm early to report the incumbent feasible solution. And because of sort of the day-to-day variation in the inputs that Joe put into this model, the structure changes every day, and we thought that retuning a heuristic could be very cumbersome and high maintenance for Joe to deal with. So like I mentioned, we needed all of the tools that we use to be freely available for non-academic use and also high-powered enough to solve a very complex problem every day. And so we ended up using the Python-based optimization modeling package Pulp and the open source solver CBC, both of which are freely available through the CoinOR initiative. And then we also used this free add-in for Microsoft Excel called Solver Studio, which is developed by Andrew Mason at the University of Auckland. And Solver Studio basically acts as an interface between the modeling package and the Excel spreadsheet, meaning that we could create a very sophisticated model, but still within this framework, this Microsoft Excel framework that Joe really wanted to use. And one nice thing about this setup too is that there's just a simple parameter in Pulp that you can switch solvers. So if Joe ever decides that it's worth it for the organization to invest in a commercial solver like Cplex or Gurobi, it's very simple for him to make that change. Here's just a little schematic of our decision support system. The only thing I really want to draw attention to here is that the input spreadsheets that Joe uses are completely separate from the spreadsheet containing the model. So he's able to have a different input spreadsheet for each day, and as new data becomes available to him, he can make those updates sort of on the fly. And speaking of inputs here, I want to give you a little insight into the types of data that Joe inputs into the model. Now, I'm willing to bet big money that this isn't the sexiest user interface you've ever seen in your life, but the reason is because, we really needed to create something that Joe was willing to work with and interact with on a day-to-day basis. So even if we created the flashiest, slickest UI out there, if Joe wasn't comfortable working with it, then this whole project was basically meaningless. And so I won't go through all of these inputs here, but I want to point out that some of the inputs, like these tutor-to-student qualifications and student-to-student feasible pairings, don't change that often, maybe once every month, maybe once every few months, while other data, such as daily tutor availability and daily student tutoring requirements, changes pretty much every day. So we really wanted to focus on making this decision support system flexible enough to give Joe the opportunity to maintain and organize all of this data that has varying levels of volatility. So because of our focus on open source solvers, we realized early on that seemingly minor modeling decisions could have a huge impact on things like solution time and solution quality and convergence rates. And one of our biggest challenges was playing this balancing act between modeling hard constraints that have to be satisfied in a feasible solution and soft constraints that can be violated by incurring some penalty in the objective function. And so the idea here is that too many hard constraints, and it might be really easy for Joe to input data that results in an infeasible problem, and that's kind of worst case scenario. Joe hits the go button, a message box pops up, says infeasible, and then he's stuck. He doesn't know what to do. He doesn't want to call us for troubleshooting. We wanted to avoid that, but too few hard constraints, and it might result in schedules that actually aren't practically able to be implemented by the school. And so we went back and forth a lot with Joe to partition the constraints into these two classes, and it was kind of its own like mini meta optimization problem to try to get this partitioning just right. In the end, we had a lot of hard constraints. I've just listed a few here. Things like an assignment can't be made if the tutor is unavailable. A tutor has to actually be qualified to work with the student in order to be assigned to them. These are the things that Joe said, if these are violated, Hopeful Journeys would consider this a no-go. Schedules that violate any of these constraints just don't make sense at all. And then we had 6 soft constraints, and these are things that can be violated if absolutely necessary. The first one is that if a student needs a tutor in a time period, they should be assigned one. And this is kind of the whole point of our model, to assign all of these students. So we want to avoid violating this constraint at all costs. So we put a very high penalty factor on this constraint. And then the other constraints, I won't go through them all, but basically they represent the preferences of Hopeful Journeys when developing these schedules. So Hopeful Journeys prefers that tutoring assignments are one-on-one, 1-hour appointments with regular staff from the same team. But these things, if needed to create the schedule, can be violated. And so our final model here is pretty simple. It's minimize the sum of these soft constraint violation penalties subject to satisfying all of the hard constraints. And I don't think it's appropriate in this talk to go through all the nitty-gritty mathematical formulation details. Those are available in our paper if you're interested. I do want to mention that we use the standard binary decision variables. So x STP, for instance, equals 1 if student S is assigned to tutor T in time period P, and 0 otherwise. And really, I like to think of this as a kind of 3-tiered optimization problem. This isn't the way it actually works under the hood, but in my mind, I kind of think of this as, okay, in the first tier, we want to satisfy all of the hard constraints. Once that's done, then we want to assign as many students as possible to avoid that very large penalty. And then only once that's done, do we want to try to satisfy all of those preferences represented by the 5 other soft constraints. So that's the way I kind of like to think about this modeling sort of framework in my head. Here you'll notice that Joe has the ability to edit these penalty factors on the different soft constraint violations to represent his priorities and make it so that he can create schedules that fit his experienced eye. One thing to notice is that the penalty for unassigned students here is much higher than the rest. One other kind of interesting modeling sort of challenge that we ran into is that we noticed that our algorithm was getting hung up a lot and it seemed to be getting stuck. And what we suspected was that this was due to a symmetry issue where we had a lot of different solutions that gave the same performance, the same objective function value. And this happens a lot in scheduling problems where you might have symmetric resources or symmetric demands, but because of all of the complex interactions between our constraints, it wasn't immediately clear how to figure out which resources were symmetric. And we suspected that it wasn't like entire tutors that were symmetric to each other, but actually individual student tutor period triples that were symmetric. So what we ended up doing was adding this small random symmetry breaking perturbation to the objective function value for each student tutor time period assignment. And not only was this incredibly simple to implement, but it seemed to work very well. And we found very good results with this sort of symmetry breaking solution. And it sort of eliminated the need to develop any sort of a priori lexicographic ordering, which is kind of a traditional approach to dealing with symmetry. And all I want to say about the optimization parameters is look how few there are. We really wanted Joe to not have to deal with the nitty-gritty ins and outs of tuning this optimization model. We wanted this to be maintenance-free. All right, so in terms of output, our tool, one of the things it outputs is, well, what were the violations, the soft constraint violations found in the best solution? And so here you'll see this particular solution violated every one of the soft constraint violations a little bit, and this is pretty typical, and there were 2 unassigned students. So here is sort of the output that Joe looks at, and you'll notice there's a tutor-centric schedule at the top and then a more student-centric schedule down below. And again, we're not going to enter this into any data viz competitions, but this is sort of the format that Joe really wanted to use. This was what he was familiar with. It made it easy for him to make adjustments if need be and to disseminate this schedule out to the rest of the school. And so a couple things to notice here, cross-team assignments are clearly indicated on these schedules with the partner team in parentheses. And you'll see here in red that unassigned students are clearly indicated. So Joe sees right away where he might need to divert emergency resources to eliminate those gaps in student schedules. All right, so as far as impact and results are concerned, Joe's been using this model since about January of this year, so January 2019. And he now reports that his daily scheduling process takes on average 4 hours instead of the 10 to 14. And so this 4 hours includes about 1 hour of solve time, and the other time is spent collecting data, inputting data, manually making any adjustments that are necessary, and disseminating this schedule out to the rest of the school. And so this time savings that Joe has, he now uses that to do myriad of other things that are important to the school, like program development. He really likes to play these what-if scenarios where he'll say, what if I want to schedule a training next Thursday from 1 to 2 p.m. for this subset of my tutors? Then he can run the optimization, see if that's a feasible thing to do, and it sort of helps with long-term planning that he wasn't previously able to accomplish. And so also Joe reports here, you can see it in bold, that the schedules are much higher quality and more accurate than before. And what this means is that those midday scrambles are basically eliminated. And so this is beneficial to both the students and the tutors at this school, and it helps relieve a lot of the stress that was on this organization. So one future work in that vein that would kind of be the next step is to not only look at day-to-day stability of the schedule, but across days, trying to make the schedule sort of the same from day to day to eliminate even more of the change that these students need to deal with. And now Joe went from frustrated Joe to happy, excited Joe over there. All right, so just in conclusion, this was a really fun, rewarding, and challenging problem to work on. It was a difficult optimization problem in its own right because of all of the things listed on the left here, but really the extra challenges on the right, the fact that it needed to be a free solution within a Microsoft Excel framework, that needed to be run daily with no maintenance, and that basically needed to be finished yesterday. We needed to follow this rapid prototyping type of framework when we developed this, and that's really what made this challenging and exciting to work on. And so just in conclusion, I want to really thank Joe and Hopeful Journeys for being such great partners in this project. I want to thank again the Wagner Prize Committee for inviting us to speak here today, and I also want to thank Andrew Mason and CoinOR for leading the initiative to make this type of freely available analytics possible. So I guess one closing note is that we think it's really exciting that this freely available software has matured to the point that it can be used to solve really difficult problems for organizations like Hopeful Journeys that traditionally might not have had easy access to such high-powered analytics. So thank you very much for your attention.